Hope and Ingrid.
Great, thank you guys very much. I'm going to ask Pete and Susan as our keynote sponsor to come on up and just share some good news with you. The 25th Polar Bear announcement, you guys, amazing, amazing job. Pete and Susan, can you share my job?
Well, I think we raised a bunch of money. We had 98 golfers registered because there was so much snow. We had 75 people, I think, that paid and showed up. And I don't know how many golfed because some bailed when they found out that they had to walk the course. I started on hole number 2, which is about a mile away from the clubhouse. All that snow, but nevertheless, we went on. I think we grossed around $16,500. A few thousand expenses, but I think we netted for the club about $12,000. Wow. Nice. Thank you to all the sponsors and everybody that showed up in the volunteers.
It was a great event. It was really fun. And everybody I've talked to said, oh my gosh, playing in the snow, it was such a beautiful day. It was like the best. And I just want to thank you all for being so supportive of the Rett Syndrome Research Trust as the benefactor, one of the benefactors of the proceeds. So thank you very much for all your support.
Great job. Thanks for sharing.
Really a great job of that whole committee. The raffle prizes were amazing. It seemed like almost everybody there won something because we had so many prizes. Thank you, Bob, in particular, again, and to the whole committee. We're forming another committee. Our next major fundraiser is the Pro-Am Day at Memorial Tournament. It's the Wednesday of tournament week. I think that's the 1st of June, could be the 2nd. And we're anxiously eager to have people join that committee as well. Parade marshaling. We have the St. Patrick's Day parade coming up, and Caitlin Ushu has volunteered to marshal our marshal. She's going to lead our efforts there. I think we already have 3 people signed up, so you'll be getting a sign-up email for that. And any questions about that, reach out to Caitlin. It's always a good time, and it's easy to do. Do we have any other announcements?
Kurt said he would help too, so.
Okay. Okay. Excellent. Kurt or Caitlin? Susan West, come on up.
I have a little project that board members have already helped out, but I would like to also ask all of your help. We are making blankets for foster children in Columbus. This is called myveryownblanket.org. And basically, it's just a little blanket that these foster kids can take from home to home. They really can't carry much. They don't have much of their own. So this blanket actually has its own label on it, which says that it's done from Rotary. But then this blanket has been made by Mike. Thank you very much. Didn't he do a fine job? Yay, Mike. But then you get a special little message on there as well. So if anyone would like to make a blanket or 2 or 5, whatever you'd like, really all you get the material. You have to cut it. You just have to tie it on both ends and then make a cute little message on there for them. So I will send out an email to y'all. And if you would like to get a kit, I'll get that to you. And our deadline is March 9th. So thank you very much. And thanks, Mike. You did a fine job.
If I can do it, anybody can do it. Okay, any other announcements? Let's welcome our esteemed sergeant, Madam Claudia, trustee.
I'll take the collection basket because I know you're going to get a bunch.
I am. Thank you. Good morning, everybody. It's very nice to see so many smiling faces here on this bright, beautiful February day. We have a lot of guests, and so I'm going to ask everybody to introduce their own guests. Dave Matthews has a guest.
Longtime friend and advisor, Matt Stewart of Forest View Financial Concepts.
He's a guest, but a familiar face for all of us. Bob, my husband,
And there might be somewhere up there And I'll be calling you later, Kat, for neglecting Lisa. And Lisa is here with us again, and we're glad to have you.
Thank you.
Mom might be up there, but in the meantime, I'd like to introduce his lovely wife, Danya. And Danya, you have a desk. Yes. Rowan takes up the back end of that room. You want to introduce all your guests?
I'm going to have them introduce themselves.
Well, good morning, everybody. My name is Mario. I'm 14 years old, and I'm from Colombia. I'm a student in 9th grade at the moment.
Good morning to everyone. My name is Andrea. I'm 17. I just graduated out of Rotary.
And Mr. In Between.
My name is Andres. I'm in 7th grade.
Well, I missed it, but I understand great congratulations were put out to the Polar Bear Golf Open Committee. So I want to thank you too, even though I had to miss it this time. You know, I've been thinking, because it's really been hard to exercise during the pandemic.
It's going to be expensive.
Now,
Kept your mouth shut.
and I know you got change, so leave it to
It was worth it.
That's an extra $2 right there.
Cold. But it's been difficult to exercise during a pandemic. You don't want to go to the gym, or I don't. So I thought maybe I'd ask what you've been doing to stay fit. Andy Keela, I'm going to start with you because you've been doing something.
He's been cracking logs.
It's the glasses.
What's everybody doing? Anybody doing anything interesting for exercise? Pete?
I wear dark clothing because it makes me look slim.
Like it's sweated out.
Well, to answer your question, not enough. Consistently, but last week went to see my sister up in Traverse City. Went ice skating Tuesday, cross country skiing Wednesday, downhill skiing on Thursday. I do that every week.
Well, yeah.
I've been watching the Olympics.
Good. Well, we've been walking a lot because some of you know I have a big old 80-pound dog and I have to walk him every day. So I've been walking, and we walk in Bridge Park, and we walk in downtown, and then we walk in Kaufman Park. And anybody else do walking? And then where do you walk? Any place special?
Through Balance, right?
Okay. Anybody else? I was just wondering, has anybody here walked in space? Everybody else $1. We have $20 in the small pot, and I'm going to ask the last 4 digits.
Last 4 are 1054. Oh, that's neat.
Oh, look at you.
Wow.
See?
Last 4, 1062.
What is it?
1062.
Claudia, Claudia, I have a happy buck.
Yeah.
Oh, we got a happy buck there.
Go ahead, Paige. Let's hear it. Paige has a happy buck.
Paige has a happy buck.
I would like to give a big shout out to Roberta Kane. The pictures from the Polar Bear Open, all 295 of them. And it was especially gracious of her for those of us that couldn't be in the Polar Bear Open. It felt like we were right there as we were going, or as I was going through the pictures. So Roberta, just wonderful. It really brought it alive. I was looking for Pete Fulbergy to do Snow Angels, so I was a little disappointed that I didn't see that picture. But thank you very much. It was really well done.
Very well done. I did see some snow angels happen out there.
It was a
Susan?
big fan on the first
Quick
one.
happy buck because the Bengals are in the Super Bowl.
Okay, I'm gonna ask Andy to come. Oh, one more. Dave
I don't
Matthews.
know if this would be $2. My son graduated from OU in December and he had his first interview and he's moving on to the second interview for one of his dream jobs at ESPN in Bristol as a technical director. So behind the scenes in sports broadcasting. So that was
Andy, come on up.
Good morning, everyone. So if you have on your bucket list meeting an astronaut or a rocket scientist, you're sort of in luck. She's not a rocket scientist, but she will do you one better. She actually gets to ride the rockets to the moon. So quick housekeeping, we ordered some books that Kathy has agreed to graciously sign due to supply chain issues that I was hoping she would have solved by now. Those arrived late last night. She didn't get home until after the books arrived. I think she was probably practicing her scuba diving or something like that. But they arrived last night. She will sign those and I will pick them up and I'll bring them next Friday. If you can't make it next Friday, we'll get those to you. So Claudia kind of spoiled part of my fun today.
Because nobody knew that?
What's that? Of course, kind of goes without saying. So our guest today is none other than Dr. Kathryn D. Sullivan. She described herself as an astronaut, of course, a scientist and an executive. I describe her as a role model for young people, an explorer, and a pilot. She was the first American woman to walk in space, and her submersible dive to the Challenger Deep in June of 2020 made her a triple Guinness World Record holder. She's now a 4-time Guinness World Record holder for the most guests at a Rotary meeting. The most vertical person in the world, the first person to both orbit the planet and reach its deepest point, and the first woman to dive to full ocean depth. Kathy was recently appointed by President Biden to the President's Council of Advisors on Science and Technology. Previous positions include presidential appointments as Undersecretary of Commerce for Oceans and Atmosphere, and Administrator of the National Oceanic and Atmospheric Administration, or NOAA, in 2014, NOAA Deputy Administrator in 2011, NOAA Chief Scientist in 93, and a member of the National Science Board in 2004. It gets better. She currently serves on the boards of International Paper, Accenture, Federal Services, Terra Alpha Investments, and the National Audubon Society. She's also a senior fellow at the Potomac Institute for Policy Studies and ambassador at large for the Smithsonian Institution's National Air and Space Museums. Kathy's been inducted into the Astronaut Hall of Fame, the Government Executive Hall of Fame, Women Aviators Hall of Fame, Women Divers Hall of Fame, and Ohio Veterans Hall of Fame. She was recognized by Time Magazine in 2017 as one of 46 distinguished first women, by the World Economic Forum in 2015 as one of the 15 women changing the world, and as Time Magazine's 100 most influential people in 2014. She's been awarded the Nevada Medal, the Explorers Club Medal, the Rachel Carson Award, an Emmy, and 9 honorary degrees. Please help me welcome Wonder Woman.
Well, thank you, Andy. I want to make sure everybody on the Zoom can hear me. I'm going to share my screen in a moment. You know, with that resume, you might think there's nothing on my bucket list, but let me tell you, Mars is out there somewhere. And I knew John Glenn pretty well, and as you'll remember, when he was like 77, he got to go fly in space one more time, and that was on the rationale that you want to get some data on flight an old fogey in space. Well, you know, you need to match that with some data on old Rod, and I figure I'm first in line. And if it happens to involve the moon, I won't.
What I thought I would share with you today, there are obviously lots of stories I could tell, but thinking of this group in particular and your very business backgrounds, I thought it'd be fun to talk today about the next space age, which is what we're in. We're watching the start of that unfold on our news and in our papers all around. But you know, behind any newspaper article, there's a lot of detail and nuance that doesn't come through. So I'm going to try to give you some glimpses of that. And then when we open up for questions, all questions are fair. There's no such thing as a dumb question. Anything you're interested in asking, I'll answer. Challenge left to you to know if I'm making it up or actually giving you an answer, but it's left to the reader to determine. But one caveat, our three young guests get first dibs on questions. So you guys get ready. So here we go. A little bit about the new space age. I can make my screen behave here. There we go. Remember these three words. Everything you see about entrepreneurialism, advancing business in space, more private activity in space, non-state actors, companies and consortia will have to do with either navigating, managing, or contributing to these three problems. And I'll touch a little bit on each of them and what we already see of them happening now as we go forward here. So this is a simple graphic to show you how the space environment around us has grown and become more cluttered since the start of the space age, which is 1957, right? Sputnik, 1957. So the upper left there, there's two little blue orbs. Well, there's two blue orbs. One is Earth looking at it sideways. One is Earth looking at it down on the North Pole. And Sputnik's too small for you to see it, but it's up there. By 1970, you see a lot of dots around Earth, weather satellites, military satellites, communication satellites primarily. And if you look on the right, you start to see a belt forming around. That's the geostationary belt where ComSats live. 1980, you see both of those densified, and then come on to 2015, the last time this was updated on the right. And it's seriously cluttered, right? It's so cluttered that the low Earth orbit, there are serious debates and concerns now that that low shell around the Earth at about 700 miles could become so dense and crowded that the risk of putting another satellite in it or going through it to get to geostationary would become untenably high. You might be willing to take it if you own that satellite, but if you have a $20 million or $1 billion communication satellite with 40 transceivers on it, you're going to want to insure that thing. And the space insurance industry is starting to look with a very jaundiced eye at the risk factors associated with getting to orbit. Some of these pieces are fairly large. You know, the leftover rocket stage that used its propellant is just drifting around. Some are quite small. They can be as small as a fragment of paint. Rocket stages with leftover fuel, and some get pressurized in the sun and sometimes explode. There are two occasions, one by Russia, one by China, where they deliberately destroyed one of their own satellites to show everybody else that they have the ability to destroy one of yours if they want to. And each one of those creates a cloud of debris. So this podium that was this big gets hit by something going really fast. It shatters into a number of pieces. Some are, let's say, 10 big chunks, but a whole cascade of little bitty chunks, which all then scatter out over time and smear along the whole orbit. So there are about 20,000 objects that are this big or larger being tracked. We can tell you where they are. We can do the math. We can tell you if they're going to come near you. But there are something between many, many millions and possibly billions that are smaller than that. They're just a cloud you have to accept is out there. And I put some numbers up here to give you a sense of, you know, how much do you care if there's a blueberry near you in space? I mean, if I throw a blueberry at you guys here, no one cares, right? It's flat, big. A blueberry, if it hits you at the speeds you're doing in orbit, has the effect of an anvil falling on your head. The momentum, you know, momentum is mass times velocity squared. So a little bitty mass, but a lot of velocity, it's going to pack a punch all the way up to, you know, softball size. So you've got, as you can see, tens of millions to millions of all these particles, and they're just kind of out there somewhere you don't quite know where, but could be nearby. So this is why most spacecraft, space stations, spacesuits even, are built with certain amounts of shielding. You take precautions like, you know, fly this way so the strongest surface of your spacecraft might get hit instead of pointing your windows. Simple things like that, just because there's stuff out there and you're not going to see it. a blueberry going by at 17,500 miles an hour, when you're doing 17,500 miles an hour, you'll hear it when it hits, but you ain't gonna see it ahead of time, unless you've got the math from the tracking systems that tell you it's there. And of course, against that backdrop, it's a little bit of an oddity that the current craze is smaller, ever smaller satellites. Several reasons, speed and cost of manufacturing, also from a national security point of view, instead of putting one satellite in orbit the size of a school bus with lots of capability, which only takes one hit from one bad guy to wipe out and blind our military. Let's put each sensor on its own little carrier bit and spread them out. So you can't blind me unless you take out 10 or 20, harder problem. And CubeSats, as you see here, have become quite small, truly the size of a coffee mug, and made out of sort of stackable components. So if one unit is too small for you, you stack several together and make it a little bigger. And you see on the right pair of what are called Dove satellites. These are built by a company called Planet that's trying to put small camera-bearing satellites up by the minis so that they can take an image of any place and every place on Earth every single day, which the older satellite architectures can't do. They can get you a picture maybe every 15 or 30 days, but not a daily update. And at quite good resolutions, you can see a useful amount of detail on the ground. So there you go. They're an opportunity and a challenge. One man's cool, easy to launch space satellite, super cheap and small, is another man's added degree problem. So how is this going to work out? And here's one of this sort of end, where could this go and sort of in the limit is illustrated here. Mega constellations are emerging in the business market. SpaceX is just one of the companies that's thinking of launching a mega constellation. This is a quote from SpaceX in yellow, but it's several years back. They already have 1,915 of their Starlink satellites in orbit. They're about the size I showed you in that earlier picture. They planned 42,000 of them, all in sort of low Earth orbit. And they're not the only company planning these mega constellations. And the business motivation here is to bring seamless broadband to every place on the planet, regardless of infrastructure on the ground. So don't need cell towers, don't need fiber nearby, rural areas, undeveloped countries. You may recall Africa skipped over the whole era of stringing copper wire to have telephone service, and they just kind of leapfrogged to the cell phone age. This could be a similar thing. We're going to skip all the fiber and the ground infrastructure. It's up there. I just need a cell phone. I'm good. But what do you do when there's 42,000 more objects in that low orbit? And here's just one of the consequences that's in the debate circles now. You see at the upper left, when one batch of these is first ejected from its carrier, they string out, as you see there, like beads on the string. And over time, they steer a little bit and move to slightly different orbits. If you're an astronomer, you're now looking up through that extra cloud of satellites. So the lower left is a long exposure, which you need to get good images of deep stars and galaxies. You take a long exposure, and in that amount of time, all those streaks are Starlink satellites flying through your field of view. And on the right, it's sorry for the little text blurb there. It's just what one astronomer said. Here's what it looks like when a satellite goes through the Hubble Space Telescope's field of view while it's trying to take these long exposures. Now, if you knock an hour or two off your observing at sunset, an hour or two off your observing time at sunrise, the sun won't be glinting off these satellites in those early dawn and dusk hours. So astronomy is not impossible, but if you used to have 10 or 12 hours of viewing time some evening anywhere on the Earth, maybe now by 8. So it's at least a productivity loss for that science. And then I showed you that geostationary belt in that first graphic where you can see it getting denser and denser looking down on it. Here's another view of that. And you don't need to read all the text. Thank heavens I don't do pie charts. But each of the little dots is a satellite that's parked at geostationary orbit, 22,300 miles above the Earth. So it seems to sit over one place and beam signals back and forth. The way to think about geosynchronous orbit, it's a finite piece of real estate. Satellites have to be within a very small level of that distance out and a very small distance plus or minus from the equator proper, or they'll drift around and won't be stable enough to use. So it's like a fixed length ribbon that's cut into little segments, and you get one segment, you get one segment, you get one segment. And once you've populated it, there ain't more room for other people. Antennas and signals will interfere with each other. So you see here how crowded it is. And only just now are really starting to get conventions among both companies and governments that if your satellite is out of fuel or it's past its useful life, you'll move it out of geostationary to some parking orbit so somebody else can use that slot. But it's a kind of real estate problem that's never been encountered in the space arena until just within the last 5 to 10 years. There's a similar one with respect to the electromagnetic spectrum. Our atmosphere is opaque to many wavelengths of radiation from the sun or from a satellite or from a receiver on the ground. It may as well be a wall. That signal is not going to get out and it's not going to get in. And you see in the upper curve here, this line shows you the 100% line up here means that nothing gets through there. Those wavelengths are blocked. Here you see what are called some atmospheric windows, and this is all the light from the sun we can see. It comes through that atmospheric window. But there's another atmospheric window out here where the red band is in the microwave region. And basically everything we want to talk to and send commands to in space, and everything we want information back from in space, has to go through that window. That's where you can carry enough signal to be useful. So your satellite TV is counting on that. Your GPS is counting on that. Broadband, satellite, ComSats, they're all counting on that. And this is another case where we've got a new real estate competition problem. Because until about 8 years ago, the only entities that had the technical ability to play in that space were governments. So they would get around a table and agree on who will use what bands, this for weather and this for TV, and sort of sort it out, and everyone would stay in those lanes. But now you have folks like Planet IQ and I've forgotten the name, Legato, come along that also want to use this band for satellite internet. And it takes kind of a lot of power coming down from the satellite to get enough signal to your cell phone. So there's the potential that these guys are going to swamp the signals we need to control the GPS satellites, to use it for navigation, to get our weather satellite data. And we've got a problem in particular in the United States that one part of the government has just gone off and licensed spectrum to these guys because that's their job. And they've got a level of independence. And all the other folks that use the spectrum, like our military, sort of woke up later and got it. Wait, you gave this to who? Wait, what are they planning on doing? You might have talked to me about that. So that's one of the other contentious real estate problems being sorted out. And what I described to you is just within the United States. Every country around the world counts on this. And that American agency has not been traveling around internationally to see if anybody else cares about what they're doing. So this is one of the most contentious issues in the space arena right now. Space has also now become, like within the last decade or so, very entrepreneurial. After many years of little bitty itses and bitses, it's just now starting to skyrocket. And I put a few of the statistics up here from a couple of years ago, what the size of this segment is, how big it's expected to go. That $2.7 trillion number has been updated already to about 3.5. Well over 300 companies now. The bulk of them still, and the major ones, the largest ones still in the launch and landing business, but a huge number of them now in small sats, in tailored services like images, where do you want images from, I'll get them for you, and increasingly space as a service. You want really tailored weather information that's particular to, I don't know, running the Memorial Golf Course during the tournament, like not Central Ohio generally, like fourth hole. We can do that for you. We're going to put satellites in orbit that add to what the NOAA weather data has. We're going to build bespoke weather models that improve what you would normally get from NOAA. We're going to build you a user interface that lets you plug in, I need to know this about that hole at that time. And we'll tailor it down to, instead of roughly this afternoon, we'll tailor it down to 10 minutes. And you don't need to care about any of the space stuff or any of the other stuff. You just buy the information. That's beginning to proliferate across a number of fronts. How about transport is one of the things that's really already quite commercialized. The first thing really commercialized in space was communications, back really into the 60s. Second thing has become transport. The top two images here are cargo transport modules. The European module on the left has been ferrying equipment back and forth to the space station for a number of months. A little cutaway view on the right of how it's equipped inside. It has to have thruster motors to maneuver it, these propellant tanks, and all the right-hand side of that image is racks and bins to store things in. And then, of course, people transporting people back and forth. And I showed here just an array of the craft that either exist or in design for basically tourism and small number of crew transport. So on the left is Richard Branson's craft, which of course has already successfully completed several tourist flights. On the upper right is Bezos's Blue Origin capsule. It's also done a couple of flights, but they're not alone in that field. And all of these little spaceplane concepts here also are imagining transport to future space stations, not just tourist rides. What about doing, and here are a couple of thoughts. Dave Berry came up with this, I thought, spectacular quote about the 10-minute space tourist flights. For those at home, maybe worth reading it out. Richard Branson and Jeff Bezos pioneer a new era in billionaire leisure travel by going up in private suborbital spacecraft. The two flights are radically different. Branson's takes off in New Mexico and returns to Earth in New Mexico, whereas Bezos takes off in Texas and returns down to Texas. Space enthusiasts say these missions will pave the way toward a future in which ordinary people with millions of spare dollars will be able to travel from one part of the state to a completely different part of the state while wearing matching outfits. And the other one I quite like is this definition of those 10-minute tourists. Sure. Astronaut is someone who writes a very big check for a very short ride and thinks that makes them an astronaut. I wrote a very big check for a ticket to Switzerland. No, I'm supposed to hear a while back. I don't think that makes me supposed to hear. Just saying. But beyond, hopping around from one part of the state to another, of course, SpaceX chartered basically a Dragon capsule to a billionaire who took 4 people to orbit for 3 days or so. So it's already expanding into stay there a while. And there are a number of concepts on the board and getting funding to go beyond stay there for 3 or 4 days. This is one of them. The module here that says Bigelow on it, it is attached to the International Space Station. This is an artist concept, but an actual one is attached to the space station now. Bob Bigelow made his fortune in budget hotels and has a vision about hotel services at orbiting platforms for tourism, recreational, whatever you might want to do. So he's testing this inflatable module right up on a skinny rocket, inflate, become a place for you to live and enjoy the space environment. And on a more ambitious scale, there's another company called Axiom that's got this modular concept and already has commercial partnerships with several leading aerospace companies to finish design and construction, and is attracting venture capital to support this, and would envision growing this out in the stages you see here. The final artist concepts are very elaborate large structures. Again, he's not going to decide what you want to do there if it's going to equip it, so you might be able to do any number of things. I can tell you, if you think it's fun to play golf in the snow or something, goofing around in zero gravity beats all of that by escape. So save your nickels now. And then, something that's happening as we speak, I felt was probably worth touching on. This is, of course, the James Webb Space Telescope. You see on the left here the kind of butterfly way it was folded up inside a rocket about the diameter of half of this room, less than, to launch, and how it looks now unfolded in space. That triangular sun shield, as it's called, is the size of a tennis court, so it ain't small. 344 separate mechanisms had to work properly for this to go from the left to right. If any one of them did not, it was endgame. So 344 single point failures. Just unfolding the sun shield, there were 107 separate little mechanisms that had to release properly, or you end up with a broken wing. It all works. It's out there. It does look like it is on the right. The mirrors, of course, were folded up in segments. And what's happening right now is each of those mirrors can be steered a little bit to make a perfect dish. And they're fine tuning and aligning those mirrors now. And just to give you a sense of the scientists like me, sort of excitement about what Webb could do, My second flight, we put the Hubble Space Telescope in orbit, so I'm a true Hubble fan. You guys can go away. You see the size of Hubble's mirror on the left here. That's how much larger the Webb mirror is. And you see the fact Hubble worked basically near the wavelengths of light that our eyes see, a little bit side to side. Webb is going to work much further out into the infrared. And what that means is, as is shown on the bottom, the Webb will be able to see much further out in space, which equals further back in time, deeper into the earlier history of the universe than Hubble can see. And that's just a really exciting prospect. So keep an ear out for what happens with Webb. They probably got there in December. I would guess by April, maybe, there'll be some first images and first data coming back. And then, of course, people going beyond Earth. There are a number of ideas out there on the drawing board being worked, engineering is being done. This is just one of them. This is NASA's concept of a lunar gateway. So it is really, really hard to get mass, people, or cargo off the Earth. So that first 200 miles off the Earth is the killer step. Anywhere in the universe beyond that is wildly easier because you're not fighting the gravity of the planet. So the idea here is let's build a staging base very close out to the moon. There's a stable orbit point where you kind of hover. And we can load that up with cargo, send people there, kind of like a base camp. And from there to the moon, a lot easier than trying to lift everything. Apollo lifted everything from the Earth that needed to get all the way to the moon back, which is why the rocket was this big and the cargo was that big. All this was get me off the planet. So how about we get off the planet and then we can assemble larger structures here. We can move more mass from the gateway to the moon than we could ever move from Earth to the moon. So what is possible to do on the surface of the moon, or to leave from the gateway and go to Mars, what is possible to do on the surface of a distant planet becomes radically different because I don't have to put it all in my backpack while I'm leaving Earth. That's the idea. Russia and China recently signed a joint venture agreement to cooperate to build a separate lunar gateway, and both have announced very serious plans in terms of government commitment and rhetoric anyway, serious plans for lunar habitation by 2030 or earlier. And both have said, with essentially a dig at the United States, but when we go, we'll stay. As opposed to, got their own back, anyway. Musk, of course, and Bezos both have similarly large dreams. This is Musk's, and he's building his big starship in South Texas to do this. Launch pad in South Texas, and he's equipping Florida for this. And he envisions spacecraft that can take up to maybe 200 people and have all sorts of amenities and move huge masses off the planet to distant destinations. His view is basically the lifeboat view. We're screwing this planet up so badly, we better learn how to live on another planet and send human emissaries there. Bezos has a slightly different view, but it is about the overpopulation and spoiling of the Earth. So we should move some amount of industry and people off the planet. So Bezos' concept is Arthur C. Clarke-sized space stations orbiting the Earth that will become a separate near-Earth environment for humans and plants and so on. I have personally a bit of a problem with both of those. They, to me, kind of boil down to two things that I find objectionable. One is, yeah, since we're screwing this up, let's just abandon it instead of, gosh, this is a rather jammable planet we were given. We might, if you left your kids at home for a weekend and to take care of the house and came home and found the trash, would that be okay with you? So we're just going to trash this planet and then go buy another one. And the other thing is, these will both turn into a version of the ultimate gated community, right? 9 billion people are not going to be saved by this prospect. A few good friends and family will be saved, and maybe lucky them. Living on Mars is not going to be any kind of cakewalk, but maybe you're lucky there. So there are a couple of tastes of what's happening in the space arena, and hopefully give you at least some ammunition for further questions or things to think about as you watch the news unfold in the weeks and months ahead. And thank you for having me join you this morning.
know, clearly, I think most people would agree it was a good idea to commercialize space transit, and NASA's role, you know, in encouraging that, I think was a good idea. Maybe the timing wasn't perfect, but what do you see NASA's role in the future? What space will they occupy versus commercial?
Yeah, NASA, I think, still has a considerable role in the future. There will be more technologies needed to advance and improve all of the things the commercial guys are doing. I think in that realm, NASA's role in space will become a bit like it is in aeronautics. So NASA works really hand in glove with the airlines, commercial air transport and cargo, because they are interested in, are there higher efficiency airplanes, are there better efficiency engines, are there advanced materials that can make our turbines, jet turbines, better, are there alternate fuels to be more sustainable? And American Airlines is not going to do that work, but they want to know it. And you know, proof of that is the couple of times that various members of Congress have tried to zero out NASA's aeronautics budget, because we have an aviation, you know, government shouldn't do anything industry is doing, and we have an aviation industry, therefore you're redundant. It's been the airlines that have let it back in and said, you don't understand how this works. This is the two parts of the same puzzle. Keep them healthy. We don't stay healthy for the long run if that engine is not healthy. So I think on the transport side of things, probably that's going to go, you know, advanced power systems, advanced fuel systems, better shielding. How's Musk going to shield his crew from the radiation of deep space? Musk doesn't know that right now. And Musk isn't doing research to figure that out. He's going to be harvesting NASA work. And
Kathy, in 2 minutes, can you tell these young folks how a geology major will become an astronaut?
Oh, yeah. So, you know, yes, what taking science classes really does for you is teach you how to be a keen observer, think really carefully about evidence and the value and weight of different pieces of information, and construct, you know, a logical argument. Put it another way, if the scientists encounter something they haven't ever seen before, maybe they're even shocked by it or a little bit backlight, their next inclination is, okay, well, I bet we can figure this out. Because they know how to take a problem apart and think it through and come up with a new answer or a new insight that lets them move forward. And you know, when I've been teaching classes in science and technology policy, one of the biggest differences I observed between students that had been science majors and those that had not was this group could do what I just said. If you threw a kind of unstructured problem at them, most of your life you're going to get unstructured problems, like no one has a clue what to do about this and there is no answer at the back of the book. So to have the toolkit that lets you figure that out and find a way to go forward is really valuable. And the students that have majored in political science and policy, they were just lost, absolutely lost. So wherever you think you're going in life, I would encourage you to take as many science and math courses as you can, whether you're super good at them or not, or have to work hard at them or not. They will be tools. You won't necessarily use some particular equation in your future, but the ways to think and help solve a problem, I promise you will use in any pathway in life you go down. Guaranteed. Yes.
Two-part question. Heavy lift and reusable space transport. Are we making any advances in either one of those? Because it seems like we couldn't support the space station. We had to rely on Russia.
Yeah, so heavy lift and reusable transport, are we making progress on those with the follow-on observation? We ended up relying on Russia to bring crews back and forth to the space station for a long time. The reliance on Russia was a consequence of a budgetary decision that NASA could not afford to start investing in the commercial guys if it was still paying for the space shuttle. So, and if it wanted to go beyond, you know, build a capability like Gateway to start going back to its roots and go beyond. So we need to cancel shuttle and start working on these other things. That's what created the gap that we decided we had to fill with Russia. It was also at a time that on a national level, the United States was interested in supporting the Russian space sector to prevent it becoming more militarized or becoming captive to China or other parties. We wanted the partnership to be with us, not with other countries. So it wasn't, it was, we didn't have the capability, but it wasn't an entirely stupid decision to go into that hiatus. But yes, you know, Bezos Blue Origin is working, we've only done tourist flights so far, but the whole Blue Origin concept is routine transport. There's 5 other companies working on that, and of course, Musk is already doing it with some regularity and good reliability. Getting heavier lift, Musk right now is the main guy pushing that commercially, and NASA's also close to launching on a test flight, a heavy lift. Okay, time for one more question, then I'm getting the hook.
The comments at the end about sending people to Mars. I've always been disappointed in our country budget for NOAA versus NASA. I think the future of the human race depends a lot more on our ocean.
I love this man. For folks on Zoom, if you couldn't hear, it was a question about the budget discrepancy between NASA, which is huge, and NOAA, which is, you know, it's like $5 billion, but that's compared to $20 billion for NASA. There's long debate there about the aspirational and national security and geopolitical dimensions of NASA and the roles that it can serve. It has a different scale of diplomatic role than NOAA has. But the other thing is, you know, what NOAA does for all of us. NOAA is the one agency in the federal government that touches every single American every single day in a way they appreciate with some valuable weather information. But it's become a hidden utility problem. We just expect it to be there. So we expect it to be there. We expect it to be ever cheaper, and free would be good. Thank you all very much.
Thank you. Our quote for today: Earth is a small town with many neighborhoods in a very big universe. Thank you again. And next week we have Ann Farley, the Community Relations Director for Gans Horn Suites. So have a great week. Have a great weekend. Thanks.